All right. Cool. Well, thank you for joining us, everyone. This is our last technical session of the year. A really interesting subject, complete streets. Kurt, Gina, and Colleen and Calvin have put together a presentation of all the work that they've been doing to put together a new manual guideline for us. So with that, I will turn it over to Kurt.
Thanks, Erica. Hello, everyone. My name is Kurt Pagnitz. I'm the design manager of the CDOT Complete Streets program. Been with CDOT for a couple of years now, and we've been doing a ton of work on really refining and adding clarity to and creating new details to help us do all the things that we want to do. But I'm going to start by kind of giving a little bit of an introduction to complete streets in general, because I think it's a term that kind of gets said so much and sounds good in marketing material, but can start to lose its meaning a little bit. So I want to kind of step back and start with a little introduction there. We'll also talk a little bit about 2023 project highlights, some design areas of focus for 2024 and beyond. We really have a ton of lessons learned from projects in 2023. We've been doing more and more than we've ever done in Chicago's history. We've installed more bike lanes in the past 2 years than any 2-year period in Chicago history. And the focus of those bike lanes has been low stress bikeways, so neighborhood greenways and protected bike lanes. So we've done a ton of really great work, but of course there's always lessons learned, and there are always things that we want to focus on and get better going into the next year and new projects. So I really want to spend some good time talking about those things. And then we'll talk a little bit about the Complete Streets Design Reference Manual that our team has been working on. This has been sort of pieced together over time, over the past few years, as we've refined new details, tried new things, piloted pedestrian safety projects, and then refined them and modified our details as we've gone along. And the state of the industry has just changed so quickly over the past decade, past 5 years, past 2 years. There's a lot of new design reference manuals coming out. So NACTO, the Urban Bikeway Design Guide, is getting an update. MUTCD, the update should be coming out eventually. The ProAg final rule from the Access Board was just released. So there's a ton of stuff happening in the industry right now, and we really want to focus, this will focus on kind of the CDOT side and complete streets in our group, but there's a ton of stuff out there, a lot happening, and so we really want to create nice, easily referenceable, refined guidelines that we can use to design projects in our group and beyond. And then at the end, we'll have a question and answer session. I do have a couple of breaks in between for questions, but we want to make sure that we have a good amount of time for question and answer at the end. So what is a complete street? Like I said, it's kind of a squishy term, but wanted to kind of ground the conversation with this to start before we really get into the engineering details. We start talking about complete streets, we really need to think from a network perspective, right? Our goal is that every transportation mode should have a safe, accessible, and functional transportation network that gets you from where you are to where you want to go, where you need to go. That doesn't mean that every single street has a protected bike lane. If you're someone who bikes, it doesn't mean that every street is a 6-lane highway if you're someone who drives, because we are all at some point too, especially in an urban environment, pedestrians at some point in our trip. Most people who bike also drive and also walk to get where they need to go, also take transit. And all of these different modes are interconnected, and each mode, again, I'll come back to this a lot, needs to provide a functional transportation network, but the key is safety, and that really underscores everything that we're talking about with Complete Streets design is safety, and we'll talk about that in a minute. Again, that's sort of our values as the Complete Streets group and as a department, and we want to develop and design and implement streets that align with those values. One thing I really wanted to touch on, because I think this is something that gets lost a lot when you're designing roads and streets on paper or in CAD. In an urban context, streets are not just about conveying traffic. They are places, they are spaces, they're our most abundant public spaces. And understanding and balancing the needs of a street between place and flow is really integral to creating a good transportation network and a good street that works for everybody who's using it, but that also meets the needs of people who use that as a gathering space and as a place to be. So touching on that a little bit, and I'll shout out to, he's not here, but Brad Huff, lead planner on the Complete Streets team. He turned me on to MobiCon, which is kind of an international consulting firm who put together something called The Good Street with several other agencies and companies. But it's a really cool document if you have an opportunity to read through it. But it really talks about some kind of basic guidelines for what makes a good street, or maybe what we would call a complete street. And it really focuses on exactly what I talked about in the last slide, balancing the needs of a street between place and flow, and understanding that each street exists in a unique context, especially in Chicago. Every street, block to block, may change context. We have so many mixed-use streets, residential streets, places that are heavy industrial. The central business district is a very different context than some of our residential streets. So understanding land use and context really matters. But the other thing that really matters is, regardless of sort of the land use, is what the primary use of that street is. And something that I really like in this document is it talks about streets as places. And one of the things that you see in this sort of gradiated chart on the scale of place to flow is that there are not a lot of streets like this in Chicago. We don't have a lot of areas that are sort of fully pedestrian areas with an emphasis on staying, as you see here. And these speeds that are shown on the top are all in kilometers per hour, so keep that in mind as well when we talk about what a fast speed actually is and what a slow speed actually is. But again, it kind of gives you the range of what a street can be. The other thing I really wanted to highlight on this chart is when you look at streets that are primarily flow streets, right? Streets that truly are not places for staying, truly are their primary reason for being is conveying traffic. Even those streets do not get out of these requirements of being safe, accessible, and functional for all modes. So this is a flow street, but you still see offset raised bike lanes and ample sidewalk space. You still see 30 miles an hour as the speed limit here, right? So these are not extraordinarily fast speeds from sort of an American highway context, but that is a speed that would be considered a flow speed. So really important to note that even on your most flowy of streets, you still need to provide safe and functional facilities for all modes. And again, doesn't mean that every street needs a protected bike lane. That goes back to the network perspective. But there should be an alternative that parallels a street if that's a desired path for people who are biking. So again, wanted to touch on the most important piece of all of this, which is safety. And big reason that we are all here. Traffic fatalities and serious injuries are absolutely an epidemic in the United States right now. 40,000 people are killed by motor vehicles each year in the United States. That's data from the National Safety Council. On Chicago streets in particular, these numbers are a little outdated. This has gone up during the pandemic, back down, so it's right about where it is. But we see 80,000 crashes, 107 or more fatalities. And something to really highlight is that bicyclists and pedestrians, while bicyclist mode share is only 1 or 2%, bicyclists and pedestrians make up 65 fatalities out of that 170. So you're talking about a third of fatalities from a mode share that's only 1 or 2%, which is, it really highlights the vulnerability of those road users and the importance of focusing on the most vulnerable users of our street when we're designing. This is a chart that everyone has probably seen at some point. I think it probably belongs in every presentation about complete streets or street design in general. It really highlights that speed kills. Speed is the #1 factor in the risk of fatality or serious injury in a crash. And the key to this chart is that as a pedestrian, at 20 miles an hour, if you're hit by a motor vehicle, you have a 95% chance of surviving. But at 30 miles an hour, only 10 miles an hour faster, that the odds of survival go down to only 55%. And when hit by a vehicle going 40 miles an hour, so only 10 miles an hour faster than that, your risk of surviving or your odds of surviving a crash are only 15%. Your odds of fatality are 85%. And this is ITE, this is an engineering group, so I thought I could put at least one equation in here, some charts. But I really think that this highlights, as you kind of look at it and dig into it, really highlights why speed is so crucial and such a huge factor in the risk of fatality and serious injury. And it also helps sort of, and this is from that the Good Street document as well, helps sort of understand the different families of modes and how they fit together, and how separating modes of vastly different mass and speed is so critical to street safety. So kinetic energy, if you remember from physics class, is energy of a body in motion, right? And kinetic energy is directly related to the amount of force that you have available to you, or a body has available to it, to transfer in a crash. It's directly related to the risk of fatality and serious injury. And it's linear, goes up linearly with mass and exponentially with velocity. So the more massive a body is, the larger a car is. And this is a huge issue, and one that on the street design side, we have less of an ability to control, as like electric vehicles are great for a lot of reasons, but they're also much heavier than standard vehicles because these batteries are so huge and massive. And so vehicles are getting heavier even as they don't get bigger in size. Vehicles are also getting bigger in size. People are buying more SUVs, more trucks. Trucks are getting bigger. And so you start going and thinking about, an electric Ford F-350, right? It's already super heavy because it's a huge truck. And then you put a giant battery in it to support that. And now you've really increased the mass to the point where that vehicle is getting more and more dangerous in the street. The piece we have more of an ability to control from the design side is speed. And again, as speed increases, if you double speed, it quadruples the amount of kinetic energy. And that is exactly where this chart is coming from, right? This is the fatal and serious injury crash risk. So speed management is so critical to what we do in the Complete Streets program and in street design in general. This is just another way of looking at the same thing. And I do this to highlight and kind of push back on some of that kind of old school traditional engineering thinking about bicyclists as another user of the street in the same way as motorists, right? And the idea of a vehicular cyclist and using the street in the same way. A bicyclist is closer in line on this chart to someone running on the sidewalk than they are to a car driving, which has orders of magnitude more kinetic energy, 100 times than someone on a bicycle, right? So they are entirely different users and entirely different categories on our street, and we need to treat them in that way. Again, both users deserve that safe, functional, accessible transportation system, but you cannot expect users of such different classes to be able to have a safe, efficient, accessible facility in the exact same way. It has to look different. So I just wanted to touch on these really quickly. I think most people in this room have used some of these design elements, so I will not spend much time on this, but I just wanted to emphasize what we're doing with these kinds of improvements. It is all about speed management. So on this top row, you see elements that we can install that produce vertical deflection. So they make it either uncomfortable or impossible to drive at high speeds typically through conflict points, right? Places where you're in conflict with pedestrians or bicyclists or other users of the street. And so we do that with raised intersections, or raised crosswalks, or the trusty old speed hump, which it doesn't get enough appreciation, right? Very effective at doing what it does. We can also do that with horizontal deflection, changes to horizontal alignment. So forcing vehicles to take tight turns around a traffic circle is going to slow them down. Chicanes, forcing you to shift to the left and to the right while you're driving on what otherwise would be a straightaway that makes you want to just hit the gas. Curb extensions that visually narrow the street and help encourage slower speeds and also shorten crossing distances for pedestrians. And something, I saw Sid just walked in, he's worked a lot with us on this, but left turn traffic calming, which is, we've also referred to this as a hardened center line. This forces left turning vehicles to take turns at a much tighter radius and reduces the conflict zone between pedestrians and left turning vehicles and increases visibility of pedestrians in the crosswalk as well. And we've seen Really, really great numbers in terms of more vehicles, more motorists yielding to pedestrians in the crosswalk, and fewer crashes at locations that we have installed left turn traffic calming. So I won't go through all of these, but similarly, so many options when it comes to road reconfiguration and adding protected bike lanes and looking at all these different types of facilities. Gino and Colleen will talk a little bit about bus boarding islands later. And again, some of our speed feedback signs, or we also have speed cameras in certain locations, sort of locations where otherwise the design we're not able to narrow the visual field, or there's long space between crosswalks and control, whether it's signals or stop control, where it just encourages high speeds. That's where sometimes speed feedback signs or lowering the speed limit can be really impactful, in lieu of other improvements that might not be possible on the street. So that's the intro on that. Any questions just off the bat on there, kind of the broad pictures? We haven't gotten into the details yet, but any questions on any of that? All right, so let's roll on to kind of celebrating what we've done for 2023. I've got a couple of things I'll talk about and turn it over to some of the folks on our team. So one thing I absolutely wanted to highlight, because this has been just a crucial, huge push for our team over the past 2 years, is the upgrade of existing protected bike lanes that were originally installed just with flexible delineators in the bike lane buffer. 2 years ago, an initiative with the previous commissioner began to upgrade every single existing protected bike lane to curb barrier protection. And we are well on our way to completing that goal in what really has been a Herculean effort that is really unique to the city of Chicago. Other cities are starting to do this, but the quantity that we have done and the speed with which we've done it has been really, really amazing. And I just say thank you to our whole team and all the consultants who have worked on this. Many people have probably in this room touched some of these projects. If you need me to pause, I can for the for the echo. Good. Yeah, it's been really incredible. We have over 25 miles of protected bike lanes that have been upgraded with either precast curb or through arterial resurfacing just this year. That does not include all the other protected bike lane upgrades that we've been doing as well. So just absolutely huge task that really proud of, and has taken a lot of work from a lot of people in this room. This is a picture of just some of the precast curbs that we've installed through this program. So this was a big effort to allow us to install and take advantage of contractor capacity to install these and get these in the ground really quickly. We're doing a lot of street paving and cast in place concrete as well. But at the same time, we can have a manufacturer working on precast curbs that then either in-house construction or other contractors can install for us on both existing protected bike lanes and new protected bike lane projects. So really this detail kind of grew from conversations with other cities through NACDO groups, and then a little bit of trial and error on piloting. You see kind of our first design for precast curb. We want to do something that we could have a single mold off the shelf and throw it out in the street really quickly and start evaluating. So the first 3 or 4 projects that we installed were installed with this type 3 curb pilot. I won't get into all the details, but we sort of refined the design over time. You can see kind of the high and wide drainage slot with a little bit of a thin shelf of concrete at the top of that slot. We found that if these were to fail or crack, that was where it was happening. And the most force that these are experiencing happens when they're installed and they're on the forklift. And so it was through that we redesigned these slightly, brought up this taper. You see now this is the new design for the type 3 with a shallower taper on both ends, narrower drainage slots. They're only 8 inches wide instead of 18. And then a higher shelf of concrete there. And there's been changes to the rebar design. But we've really honed in on a precast curb design that has proved to be really robust. These are holding up very well. We've installed over 10,000 of these this year. They're 8-foot curb units of curb. And we've got more that are continuing to be manufactured. So this has been really useful for us to be able to get a lot of stuff into the ground very quickly. And I would note too, we also use prefabricated fiberglass curb called Quick Curb. And we use this on usually bridge structures. Reason being, these precast curbs require anywhere from 6 to 12 inches of embedment. They're embedded with epoxy coated rebar that is grouted in place. But they require a deeper depth of embedment than Quick Curb. Quick Curb we can do as shallow as a 3.5 inch embedment depth. And we can also install these without any embedment at all with a 2-part epoxy on concrete structures. So we've done a lot of that on bridge structures in lieu of precast curb. It's still a nice high curb. We install bollards the entire way through. We've seen, a lot of good feedback and success on those installs as well. And this is just kind of an isometric view of those. Kind of talked about it already, but each curb includes 3 donut holes and slots where the epoxy coated rebar is drilled and then grouted into place. And then these things can be removed and replaced if there's any utility work that's going on, anything like that. If they're not made to just be removed and replaced over and over again, right? So once or twice might work, but if they're damaged, they would need to be replaced if there's any utility work going on. And we have details for these that are available for people to use as needed. These are just a few pictures of those precast concrete upgrades. These are some of the downtown projects that used the type 3 curbs. The names of the curbs, type 1, type 2, and 3, really simple. Type 1 is just our narrowest, it's 8 inches wide. Type 2 is 1 foot wide, and type 3 is 1.5 feet wide. And then I'll hand it over to Gina here to talk a little bit about some of the new projects and new protected bike lanes.
Sounds good. All right, so as Kurt mentioned, we used precast a lot this year and last year to upgrade already existing protected bike lanes, but we also actually used precast to install brand new bike lanes this year. One of those being Kedzie Diversity to Elston. What we did was swapped the parking and the bike lane, so the bike lane is now curbside. And as Kurt was talking about before, our biggest effort is speed management. You can put up speed limit signs all you want, but they often get ignored. So the way to slow people down through pedestrian and safety enhancements is also to visually narrow the street. So by putting the parking lanes on the inside, it forces people to slow down that way. We also did end up signing Kedzie as 20 miles per hour. And since we've done this project, we've already seen a 90% reduction in people going over 30 miles per hour, which has been huge to see. And there was also other pedestrian enhancements. There were paint and post bump outs, raised crossings through here as well. Kedzie was really important to have 2 major connections along the corridor, one of those being to Belmont, which Colleen will talk about in a little bit. And then the other one was Wellington from Kimball to Kedzie, as you see on the bottom right here. This one is a neighborhood greenway that it has a contraflow lane and a former slip lane that was converted into a paint and post bump out. And that connects you between Kimball and Kedzie. And then another precast new project we did was on Augusta from Western to Milwaukee with an off-street connection to Elston. This was our pilot for a 42-foot wide roadway with parking protected bike lanes on both sides of the street. And we used type 1 precast concrete, the narrowest one, as Kurt mentioned. This included a reduction of speed to 20 miles per hour. Almost every unsignalized intersection has paint and post bump outs, and there's other enhancements on the street. This was a priority of ours because there are multiple schools and daycares along the corridor in this section. Last year in 2022, our team did observations along the corridor, but especially at these schools and daycares, and found a ton of issues with double parking that was causing people to swerve around the parked cars, causing visibility issues, causing a lot of safety issues. And we've since then done, after observations, now that the street is constructed, we see virtually no double parking. We've seen a lot lower of speeds, and it's been a huge improvement. So we're really excited about this one. We also have done protected bike lanes with cast in place concrete this year. And that would be Belmont, Kimball to Western, and Polk Damon to Ashland as 2 of the main ones. We've been able to do a lot of these through the arterial resurfacing program and our collaboration with them. Here's a photo of the cast in place concrete being poured. We'll talk a little bit about this later, but with cast in place comes a little bit more maintenance of traffic. As you can see, there's lane closures and bike lane closures. So that kind of affects what type of concrete we end up using, but we will talk about that later in the presentation. We've also done a lot of rapid delivery pedestrian safety projects. Kurt referred to it earlier, and Sid can answer some questions at the end more about that. He's in the back. We've done a lot of paint and post bump outs throughout the city, both mid-block and at intersections. And we've also done left turn traffic calming through the use of rubber speed bumps and quick curb. Going forward, we'll be using more rubber speed bumps than the combination with quick curb. And in 2024, we're going to do a lot of observations at these locations to see if there's anything we can improve on. Just on Monday, we had a ribbon cutting with the mayor and our team for the Central Park ribbon cutting. It was pedestrian and bicycle enhancements in the Garfield Park area on Central Park. And this included a raised crosswalk, connected bike lanes, refuge islands, more enhancements. It was very successful, and that area gets used by so many tourists, and there's so many people going through to see the conservatory and the park. And so this was very successful, and we're excited to get this one in as well. And I'll hand it over to Colleen to talk about Belmont.
All right, so Belmont is a project that our team has been working on and focusing on for the last 2 years. There were a lot of things in the existing condition on Belmont that made it stick out as a corridor in need of improvement, including its classification as a Vision Zero high crash corridor, its complex intersections, high speeds, and uncontrolled crossings. But however, there was a lot to gain if we were able to make major improvements on Belmont. The 3-Run-2 River Run Trail connection is lets out on Belmont, and the possibility of providing an east-west connection for bikes to get over the river, considering the nearest ones were pretty far away, would be major improvements to this corridor if we were able to transform the street. Here is a few photos of the existing conditions of the western portion of Belmont. And you can see Belmont looks pretty much like any other arterial street in the city of Chicago. It has wide through travel lanes and multiple lanes in either direction. And this is primarily due to the low utilization of the existing rush hour parking controls on Belmont. Also, the pedestrian infrastructure at major pedestrian generators like the strip mall shown here was in pretty poor condition. And another challenge was that Belmont at Kedzie is underneath the Kennedy Expressway. So not only is it dark, but there's also a lot of cars entering and exiting the highway at high rates of speeds. Moving to the east, the cross-section of Belmont remains the same, but the context of the street changes a little from the more commercial side to the west to a little bit more residential to the east until we get to the bridge that crosses Belmont, that crosses the river at Belmont. And in that bridge picture, you can see the 3-Run-2 River Run Trail exits out, and bicyclists basically have to either decide to walk their bike down the street for a block or to chance themselves to the high speeds on Belmont over the bridge. So the existing cross-section of Belmont is 51 feet, and it's pretty much an undelineated space shared by bikes, cars, and buses. And we were able to transform it into a more complete street where bikes, buses, cars, and pedestrians are better served. There are concrete end caps and protected curbside bike lanes that help separate bike lanes fully from motor vehicle traffic. There are bus boarding islands allowing pedestrians to board the bus and encouraging slower speeds as cars wait behind these buses as they load and unload. Also, we have fewer and narrower travel lanes for cars that encourage slower and more careful driving, as well as actually lowering the speed limit from 30 miles an hour to 20 miles an hour. Like I mentioned before, Belmont and Kedzie is underneath the Kennedy Expressway, so it's dark, it's busy, and it's confusing as a car trying to get through an intersection this large, let alone a bike. Also, as Gina just mentioned, Kedzie was upgraded to concrete protected bike lanes. So this was a perfect candidate for us to implement the first fully protected intersection in Chicago. There are concrete end caps and full stretches of curb that fully separate bikes from motor vehicle traffic. And I want to point out that it was really important for us to maintain this as a connection, because an intersection this large to a less confident bicyclist might make the difference from them choosing to use Belmont at all. So we have seen a lot of success, and also a lot of people interested in us doing more of these treatments in the future. This is just a close-up of the northeast corner of that intersection of Belmont and Kedzie, basically showing that even, greatly changing from the existing condition, there is a lot of space to fully separate bikes from motor vehicle traffic. At that same intersection, we have a picture of someone waiting in the protected space. And even with cars entering and exiting the highway and higher than average heavy vehicle traffic, this is still a very comfortable space to wait in order to continue across the intersection. We implemented about 7 bus boarding islands throughout the corridor on Belmont. And this provides pedestrians a space to wait for the buses, but it also has the secondary benefit of reducing the pedestrian crossing distance over that 51 total feet of Belmont. Also, I'd like to point out in this picture, on the bike lane side, the curb for the bus boarding island is mountable, which makes things easier for our maintenance equipment like snowplows to get through. We have a few sections of bus bike lanes on Belmont, especially at places like the Kimball Transit Stop, the intersections at Elston in California, and on the approach to Western Avenue. Finally, we have a short section of 2-way protected bike lane on Belmont over the section crossing the river. We have used quick curb, like Kurt mentioned, as a suitable alternative to concrete. And we've also provided a ramp for bicyclists to get from street level to sidewalk level to make this connection over the bridge. And with that, I'm going to open it up for any questions on the projects that we've done recently.
What's the design vehicle for Belmont?
So Kedzie is a boulevard south of Belmont, and so we were able to use a smaller design vehicle. Just there's no trucks coming northbound on Kedzie there for that right turn, and that's actually why that corner is a little bit bigger. But the other design vehicles, I think we ran an SU30 as the design vehicle at Belmont and Kedzie, and I can't remember, is it WD50?
I think it was 55.
55,
Yeah.
okay. Because there are a lot of trucks coming off that. So the geometry of the departure and approach legs and it being 2 lanes really helped make that work. Like, we don't love big intersections, but it was big enough that we were able to accommodate the control vehicle without sacrificing the corner protection.
We have a couple of questions just from the webinar part. We have 3, so let's just go through this pretty quickly. 1, how have you worked with your partners in the fire department to incorporate speed management measures that may impact their emergency response times?
Is that a question from the fire department or?
It's by an anonymous attendant.
Okay. Yeah. So in general, it's project specific, right? We how the OEMC or the fire department or whoever is using the street is going to vary based on location. So we really try to identify specific locations where maybe we're constraining the street, we're doing a road diet, it's 1 lane each direction now, where we need to have those conversations. We kind of have them on a project specific basis. We also look at basically like distances between intersections, clear width at our nearest locations. I can think of like a project we just installed on Clark Street, right? We maintained a 7-foot curb to curb width so that there's room for motorists to be able to pull to the side if a police vehicle or fire truck is needing to get through. And there's actually a fire station on Clark. This is in Edgewater. But yeah, it's really case by case, and we're looking at all those things on each project.
Thank you for that. Another one is, Can you comment on the impacts of the rapid expansion of barrier-separated bike lanes on winter operations and how the city plans to maintain the system through the winter?
Yeah.
Additional plowing resources, etc.
Yeah, totally. This is something that we had to think a lot of it when we started this program. So when we, I guess I can stand up. When we first started doing this, we met with our in-house construction folks and talked through what their existing capabilities were and then what their capabilities were to maintain additional protected bike lanes. It actually, with the upgrades, was not a huge lift because our in-house construction crews were already maintaining those protected bike lanes, even though they were just delineator separated. So we actually have small equipment, they're called multi-hogs, that are specific and smaller than your normal plows that both plow the bike lanes in the winter and also do street sweeping in the bike lanes in the other months. And so we've actually increased the number that we had. I think we started like 8 years ago or something with like 3 of these. We've tripled that. I think we have 9. Don't quote me on the exact number, but it's about 9. And then every year we create a maintenance map for in-house construction with every single project that has ever been installed, including the ones from that year, to hand off and put on their maintenance schedule. So we work with them very closely in all these projects.
Okay, and we have 2 more. One of them I'll switch together. Has there been any negative feedback related to the floating bus stops having the bus stop within the vehicle travel lane? And then the other one is, after speaking to bus drivers on the 77 Belmont bus, they almost universally dislike the improvements to Belmont. Is there consideration for education of bus drivers for these safety improvements?
I don't know what you mean. We never get complaints. Yeah, absolutely. We work really closely with CTA, and whenever there are changes to CTA operations, like there's going to be a transition period, regardless what those improvements are. That was a huge transformation to the street. That is something that was, a decade in the making. So there's no way to transform a street like that in this way with such a positive impact and not, have a transition period and have there be challenges. So we work really closely with CTA, and a lot of it is just changing and refining operations to suit the new configuration. We've worked through that on a whole host of projects. Again, like a complete street is, especially in a context like Belmont, where there are no alternatives for bicyclists, right? A complete street really like that needs to accommodate all modes safely and efficiently. So, there's always friction and challenges, but I think we've done a really good job working through those.
Okay, so from what I understand, we have more presentation coming, so we'll do this one question and then the rest of them we'll do at the end. The last question for this part would be, have there been drainage/maintenance issues with the smaller opening in the precast curbs that is trashed, etc., and how is snow removal handled in the bike lanes?
Yeah, drainage issues, no. They're both slotted and gapped, and we'll show those details later. So no drainage issues. In terms of maintenance and street sweeping, because our CDOT crews plow the bike lanes and then streets and sanitation plows the streets, they don't always happen at the same time. So you may get like trash buildup on one side of the street or the other, because of that for a short period of time. So, it's gonna, capture some debris, especially in the fall. We'll get leaves built up and everything like that. But that's part of why we have sufficient buffer space, make sure that our lanes are always accessible. So no major issues.
Sounds good. All right, we can move to the next.
Awesome. Calvin, you might have to. Light is on, but no one's home. Okay, am I doing that?
Yep.
Perfect. We're good.
All right, so before we get into more details of the design reference manual, we're going to talk a little bit about high-level areas of focus that came from a lot of lessons learned over the last couple of years. And the first being something that's actually not going to go in the guide, but as kind of a supplemental document, and that's the Complete Streets Design Process Table. It's a table that is supposed to be as sort of a checklist for consultants and ourselves to make sure we're hitting every step in the process. It's organized by the type of bicycle facility and also the round of submittal that we do internally. And it also tells you that which member of the design group should be handling which tasks. And this came from lessons learned of certain things missed, like traffic counts or ordinances, things that can get overlooked when you're busy and when you're rushing. So now we've created this. This is just supposed to be a tool to help everyone working on projects like these. And if you aren't working on projects like these but want to see something like this just to help your process, then we can share that as well. One of the biggest things that we do in terms of coordination for any project is understanding the impacts to existing curbside use. Businesses often will rely on undesignated curbside space for their access and deliveries, and that's not captured in existing signs and on the sign plans. So we recommend doing observations and data collection for all projects that are going to be impacting the curbside use so that you can understand how it's being used, especially for those undesignated areas. It's really important for the success of a project to understand these, because we work with the public and businesses to ensure that these needs are met and that we're completely capturing them all in the design. This also goes with when you're either reducing the street width or adding end caps that could be affecting the access. So you should be running auto turns for items like that as well. On our team, we have an Excel spreadsheet that calculates changes to the curb, especially for things like parking. This is an example that we did from on Milwaukee from North to Armitage, where we have it calculate block by block what the existing and the proposed is. Then we can see if there are any issues and really how much you're losing or gaining and kind of go from there. Another big thing to do when you're doing these projects, especially at the beginning, is assessing the pavement condition. This is important for many reasons, one of them being understanding the need for any resurfacing. And that actually helps guide what kind of facility we'll be doing, especially what type of concrete. So if we're doing, if the condition is bad, like on the left, and you have to resurface anyways, it usually makes more sense to do cast in place concrete since you're already resurfacing. And then if it's good on the right, like it was for Kedzie, you can go ahead and just drop the precast units in. CDOT also has a bike parking program that's led by Riley in the back. If you want to wave, that's Riley. It started in 1993, and we have anywhere between 15,000 to 18,000 bike racks in the city, which is huge and one of the national leaders in any one city. And we've been working to install about 400 new corrals and racks every year. And a big effort of those recently have been the placement of these corrals. We've been placing them in areas of no parking, as you can see in this photo. And the benefits of that is to prevent illegally parked and idling vehicles that often use these spaces. And when they do use these spaces, it blocks visibility and creates safety hazards. So putting the bike rack here is really helpful for that. You just have to be mindful of the placement of it, especially for utilities. It can't go within 1 feet of manhole and utility lid, and it can't go in within 15 feet of a fire hydrant.
Oh, hey, back to me. All right, something else that came up pretty recently that I wanted to go over this meeting with kind of CDOT materials on this is we've been doing a lot more cast in place protected bike lanes. We've also been doing a lot of narrow protected bike lanes on narrower corridors. This 6 foot minimum clear width from edge of pavement, or I'm sorry, from face of curb to face of curb. That is our standard that you'll see over and over in some of the details that we're going to talk about. So always keep that in mind. That is our clear width to allow our maintenance vehicles to be able to get into the protected bike lane for sweeping and snow plowing. So that minimum clear width is a really important dimension. But the other really important dimension is the minimum width from edge of pavement to edge of pavement. So the preferred surface material for any bike lane in the city is HMA, right? Asphalt is going to have a much cleaner, smoother ride. You don't need to worry about joints in concrete. So our preferred material is HMA. With that said, this was definitely a lesson learned the hard way, is that a lot of the contractors in the city of Chicago, the maximum width or the minimum width that they can pave with existing paving equipment they have is 5 feet. So if you had a gutter pan on the bike lane median side for any reason, there's drainage issue or something, and you have a gutter pan here, that distance from edge of pavement to edge of pavement still needs to meet that 5-foot minimum width. So that's just something to bear in mind if you had a 1-foot gutter pan here and 6 inches here. Well, now this is going to need to be 6.5 feet to be able to get you to 5 feet here. Something else that's come up on a lot of projects and something that we've been talking with forestry on, and that's come up is that where we can, and it's sometimes challenging with a lot of rapid delivery projects, it's challenging with utility impacts and going through the OUC process, which I'm going to talk about in a minute. But where we can, we really want to maximize pervious area. We want to maximize landscaping. We want to maximize the amount of grass space that we have. Wherever we can avoid just creating a sea of concrete, if we're doing a big bus boarding island or big bump out, especially with attached curb extensions, if there's existing grass landscaping or parkway, we just want to extend that grass parkway. We don't want to fill that in with concrete if we don't have to. The big key, like I mentioned, is utility impacts. If you're going through the OUC process, if you have a water main under new pervious area, that can be sometimes not allowed by DWM. So you may run into that in the OUC process, but we always want to start from a place of adding as much landscaping as we can on these projects where appropriate. And same thing with tree planting. If there's an opportunity or if there are locations where there used to be trees and there are no longer, and we're coming through with a large corridor project, it's something that we want to keep in mind. Again, it's been kind of challenging on the scale of a lot of our projects, but something that we want to be doing more of going forward. And then I see Tyler in the back. So this is another one where if you have questions on him on this, you can ask it as well. But I wanted to give a little bit of an overview of the signal upgrade and signal modification process, particularly because on the Complete Street side, we have been doing a lot more signal work and have been finding a lot more need for signal work, whether that's dedicated bike signals or bike signals for signal separation of turning movements across a protected bike lane. Or maybe a one-way street with a contraflow bike lane where we want to install a dedicated bike phase for that contraflow movement. There are a lot of opportunities for really impactful signal improvements. But for our team, we hadn't been doing a lot of that in the past. And so we really learned a lot about this process, how to streamline it, how to do it right. So wanted to give the very general overview and know that there are many more details to this. But, and Tyler, you can correct me if I hit anything wrong here. But in general, once you have a concept for what you're going to do at a particular intersection, you're going to put together a traffic signal requirement plan, or TSR, and that is reviewed by traffic safety. So that's Tyler in the back and Udola, who I think might be on the call. So they will review the traffic signal requirement plan. This shows locations of signal heads. It shows your proposed phasing. It doesn't get into the details of, what your restoration plan is, or your conduit and all those things, but it's going to show what are all the materials you need, where are they going to be placed, where are you placing your signal heads, what's the phasing. So there's a lot of detail that goes into this, and we really want this to be as high quality and well QC'd as possible when it gets into traffic safety's hands, because they get a ton of these to review. There's a lot to go through, and the sooner that we get these initial TSRs approved, the sooner we can move forward on the rest of the process, because these will need to go through the OUC process as well, which I'll talk through in a second. So once you complete the TSRs are approved by traffic safety, you can then submit the TCSs, that's traffic control signal plans, to the electrical section. So the TCSs will show all of your new and proposed cable and conduit, all of those details. We include restoration plans for the OUC process, which I'll talk about, but that's the next step in the process, and that goes to the electrical section. Once the TSRs and TCSs are reviewed and approved, you're in business. You're doing great. Then at that point, you can submit the timing sheets, which go again to traffic safety. And then if you are replacing any foundations or installing new foundations or installing new conduit, anything that requires any excavation, if you're doing underground work, the TSRs and TCSs have to go into EFP review in the Office of Underground Coordination, which many of you are probably familiar with, but I will talk about it. So once you work through the EFP process, you get permit issuance authorization, so you can actually do the work. And then you want to make sure that your timing sheets are approved by traffic safety. These two things can happen in parallel, but you want to make sure that these timing sheets are reviewed well in advance of this work getting started or as it's getting started, because DEO will take those timing sheets and it takes a couple of weeks to test those timings before they're able to actually get them out in the field. So it's really critical that as soon as you have TSR and TCS approval, if you need to go to EFP, do that right away. And you always need to do the timing sheets, do that right away. So that's kind of the process. And then ultimately that leads to new signal equipment and timings out in the field. So this could be a whole presentation in and of itself, but I'll give you the briefest versions here if you're not familiar with the EFP process. So any work that you're doing in the city of Chicago that involves excavation needs to go through the existing facilities protection process, which is through the Office of Underground Coordination, or OUC. The key lesson learned on our end and the key piece to remember for projects that you're working on for CDOT is that you really want to identify any locations that are going to require an EFP submittal as early on in the design process as possible. Because this review process involves 20-something agencies, and it can take several months to approve a project in OUC, in the EFP process. And you cannot start work, you cannot start underground work and pull your permit until you have EFP approval. So it's really critical that these types of locations are identified really early on in a project and submitted for EFP as early as possible. And then constant communication about the status of these projects in EFP and really, really strong design plans that are well detailed, well QC'd, are going to make that EFP process much smoother, because you don't want things to come up in the EFP process that maybe you didn't think about when you were originally doing design. And we'll share some of the slides. I've got the URL down here if you want to read more about the EFP process. So the other thing I really wanted to mention here is design and control vehicles. This is something that we've been talking about and working on a lot on the CDOT side in thinking about making sure that we're using the appropriate design and control vehicles for the context. And we have some guidelines that we've developed and ultimately will share with folks, once we're completely done. It's draft now, but I think we're really close on that. But I want to emphasize that they are guidelines, and I want to talk through sort of the guiding philosophy on design vehicle selection. So just in case you haven't heard these terms before, a design vehicle is the frequent user of the street that's going to dictate your minimum required turning radius. The design vehicle typically should not encroach into adjacent travel lanes. It may sometimes in certain instances, right? Again, guidelines. Every street, every intersection is different. But typically should not encroach into adjacent travel lanes, particularly travel lanes in the opposite direction. Control vehicles, on the other hand, are infrequent large users of the street. And control vehicles may turn using multiple lanes and in some cases encroach into lanes in the opposite direction. So we use both of these to study, all right, say, do we have enough width for emergency vehicle access in the rare instance that we need it? But are we also making sure that we have a right-sized intersection that reduces speeds and is safe and comfortable and accessible for all users? So, as I already said, and will emphasize again, pay close attention to the context of the street when selecting a design vehicle. What we don't want people doing is just looking at the table and saying like, all right, this is an option. I'm going to apply it here because it's one of the options. Land use is particularly important, and I'll get to that in a second. But functional classification is a nice guide, but in an urban mixed-use environment, it's not the be-all end-all. It's particularly important, and this also goes a little bit back to curbside use too, and those observations we talked about, is identifying where existing businesses might require large vehicle access that we just don't know about by scrolling in Street View. Businesses open and close all the time. Businesses have different uses all the time. And you may be able to get some of this in Street View too by seeing where there's a loading dock that you're not expecting that connects 100 feet away from the driveway that's actually on the street. And oftentimes, we found that large trucks are using the entire width of an existing street just to access a driveway. And we're proposing protected bike lanes. And those things aren't incompatible, but they require careful attention and detail and design and conversation. So they're the kind of things you want to be thinking about in these projects. That said, we are looking for the smallest possible standard curb radius to be installed at all corners of all intersections. So we don't want to choose a smaller than, we don't want to choose a design vehicle that's too small for what's already using the street, but we absolutely do not want to install curb radii that are way too wide that encourage unsafe, faster speeds. And you can accomplish some of this too by just observations or even just traffic counts by vehicle classification to understand what types of vehicles are using a particular intersection or driveway. And then I wanted to mention CDOT and IDOT have worked together, and earlier this year, there was an MOU signed between IDOT and CDOT that was basically an agreement that allows CDOT to restrict trucks, heavy vehicles by length on local jurisdiction streets. So not just necessarily local functional classification, but local jurisdiction, CDOT jurisdiction. And where we do that, we are able to use an S-Bus 40 control vehicle, or what IDOT calls a design vehicle with encroachment. The design vehicle cannot encroach on the state jurisdiction route, but it can encroach on the local jurisdiction route. We have I'll make sure there's a link to that MOU in here as well. But that is an option when we have a local jurisdiction route that intersects a state jurisdiction route. We want to do improvements that might restrict access to a larger vehicle on that local route. If we are not restricting truck vehicle access via sign and ordinance, then any state jurisdiction route still will need to reference the standard BDE design table. And the last thing I'd mention too is be sure if you have a project that is receiving state or federal funds that you're using the appropriate design guidance for that. It may require use of the BLR, even if it is a local jurisdiction street. Don't assume that it does, but it might. Check. So this is something that's been really important for us to be able to really get some robust, excellent traffic calming improvements on especially our protected bike lane projects, is use of the DL23 design vehicle. I think a lot of people used to the BLR, the BDE, are used to the SU30. That's sort of the smallest IDOT design vehicle that they use. And this is another thing I think that can get lost in the pages, is just how big an SU30 is. It is a big ass vehicle. It is very large. A DL23 is your standard like FedEx, or the Amazon vehicles might actually be a little smaller. They got some varied sizes. But your standard delivery vehicle that, again, is this definition of a frequent user, is typically going to be that DL23. And we've really used this on local to local intersections and some other locations where we know there's not a lot of heavy vehicles. We're really pushing to use this DL23 when needed to support the complete streets infrastructure that we're proposing. Again, not in a vacuum. This is all context sensitive, and we want to make sure we're maintaining access for existing vehicles that are using a given intersection or street. But this has been a really powerful tool in our toolbox to help really, especially when it comes to protected intersections and things like that, really expand our toolbox. Control vehicle that we use is the S-Bus 40. It's the same thing that's referenced in the MOU. And it's really because it covers so many things. It's got a wider turning radius than, say, like a garbage truck, sanitation vehicles, EMS, most fire trucks that you'll see in the city of Chicago, school buses, standard CTA buses. So this S-Bus 40 is basically our standard control vehicle for those local intersections. And then I wanted to throw this up on here just to, again, highlight the importance of context sensitivity. Does anyone in this room want to guess the functional classification of each of these portions of Ravenswood?
arterial
Which, for this one?
for the one on the left,
Okay, and then this one?
also arterial?
So I'm glad you guessed that. The one on the left, actually to my surprise, given the residential context, is a major collector. Whereas this one is classified as a local street. Promise you I'm not making it up. This is Ravenswood and Leland. So this portion of Ravenswood is all considered a local street. And yet, industrial context, trucks use this street all of the time for this particular business. And if you were just looking at this and said, okay, local street, you select your DL23 design vehicle for this intersection, and I would be answering some very angry phone calls. Whereas here, if you looked at this, you'd say, oh, well, it's a major collector. Maybe I need a larger design vehicle. But in truth, this is a one-way residential street that dead ends 2 blocks over, and there's no reason to run WB50 or an SU30 or yeah, even an SU30 through here. So again, the context sensitivity is really important. That said, I will finally show you the table. So again, this is draft, but this really gets at using what people are already very familiar with, which is functional classification, and using that as a starting point to give you a guidance on what design and control vehicles to use. And if you put this up against what you'll see in some of the IDOT standards, these are much smaller design and control vehicles. And it's very intentional. It also gets back to a little bit of that place to flow purpose of the street. Many IDOT streets are not going to fall into that place reason for being, right? They're more flow streets. And again, doesn't mean they don't need to be safe and accessible, but there's a little bit more of a reason for the larger design vehicles in that context. But local streets, local jurisdiction streets, we really want to minimize the design vehicle size to the extent possible. So again, this will be coming soon. We will share it, I promise. But some refinements. But the thing that you'll note is all of these are ranges of potential design vehicles. In general, again, we want to lean towards using the smallest design vehicle possible in a location. But you need to understand what's actually out there in the street. And then this, I won't talk too much about this, I already mentioned it, but just a note that the ProWag final rule was released and we are expecting MUTC updates. On the website, it actually still says by the end of the year. I would not hold my breath. I'm assuming that's going to come next year, but just an FYI. And then I'm going to hand it off after just one more slide here, but really wanted to set up this complete streets design reference manual. And then Calvin, you'll finally get to hear from, talk a little bit about how it's used. But again, this is the same thing you've been hearing me say. We've kind of compiled all of these details and standards and references to help guide design, not do design. And there's a lot in here that shows example streets, and no street that you're designing is probably going to look exactly like the street that's in these guidelines. It's meant to be used for just that reason as guidelines. It documents a lot of the critical design constraints, like minimum widths we talked about, minimum lane widths in different contexts that I think are the kind of things that people kind of been yearning for, want to know, like, all right, what's the smallest I really can go? This has got this. So I think that's really going to be helpful, and we'll talk through those things. But at the end of the day, we are designers, and nothing in the guide replaces the need for thoughtful, context-sensitive design. The other thing I really wanted to say too is I happen to work for CDOT, and we happen to have an in-house team that is here all the time. But that is just the role that I have and the badge that I wear. There are a ton of really, really smart, talented engineers and people of other professions in this room that have a lot of expertise. And everyone is an expert in something, but no one is an expert in everything. I certainly can say that about myself. So I just wanted to say, talk to us, share that expertise. You do have a lot of influence and power to move the state of the practice forward and influence these design standards. And if you see something and say, like, actually, I've seen this done somewhere else and I think it was a little more successful, or are you sure that's actually the minimum because I think that this vehicle could actually fit into this space? I'm very open to those things. And so I just want you to remember that as you're reviewing this guide and not taking it as someone else's gospel, but really as something that is a living document that can expand and change. And we don't want this to in any way stifle the creativity of all the really smart people in this room. And with that in mind, I'll hand it over to Calvin Graham to talk through the guide. All right, so for some of you, this is the meat and potatoes because you're going to use this every day for the next, I don't know, 5 years. For some of you, it's just potatoes because you'll never look at it ever again. But one of the struggles we've had in the past with our standards, with our guide, is that we kind of were adding things as they were needed. Oh, now we're doing a protected corner. Let's add that somewhere, and it was just kind of appended to the end, which is great because we had all the information, but not necessarily the most structured. So one of our goals with this version of the standards and these guidelines is to kind of structure it a little bit better, allow for room to grow in the next couple of years. So it is currently divided into 11 sections with 3 appendices. I kind of grouped them by color here, only just to kind of say how they function, how they work. The first 3 that are in orange are general guidelines, things like those minimum lane widths, things like general pavement markings, things that you're going to use on almost every project if you're designing a complete street. Second is some like specific, context-specific guidelines. So for specific bike lane types, like neighborhood greenways or protected bike lanes. And then also getting to specific intersection types and how we can treat intersections. Now the third section is kind of a grouping of a couple different things. A lot of our work is in collaboration, as Kurt and Gene have mentioned, with the arterial resurfacing team, in collaboration with CTA, so many other stakeholders. And so these are kind of chapters that rely a lot on that collaboration, and so they don't necessarily fit within like a program that's only a neighborhood greenway. And so that includes transit facilities, that includes raised bike lanes that are often in collaboration with CTA, that includes traffic calming, where we're working with traffic safety, traffic studies, older people. It also includes maintenance of traffic, which I'll hit on in a second, but has kind of been a little bit of a blind spot for us in the past. You know, as designers, we see it until the paper goes out the door, and then we see it when it's installed. And sometimes in that in-between, there's maintenance of traffic disconnects. So we'll talk about that in just a second. And then the appendices are a collection of 3 things. One is design criteria, kind of general, broad, look at it from 10,000 feet. What is the approach to how we're designing and choosing these design vehicles? That's the kind of thing that will be in there, so tables. We'll also have some hardware, some like specific things like bike racks, things that maybe the Complete Streets team isn't developing ourselves, but we're working with others or we're implementing a lot. And then also interdepartmental standards. As I mentioned, we work with a lot of other people. They do a lot of things way better than we can make them ourselves. So it's really helpful for us to keep these close at hand, keep these in our appendix, even if we're not creating the standard for a specific detail. So the sheet naming, we have a lot of acronyms in engineering. I'm adding one more to your repertoire. The CS just stands for Complete Streets, nothing more, nothing less. So each sheet is labeled as this CS and then a section number and a sheet number. The reason we did it this way is just in the future, we kind of are looking at maybe yearly updates to this. It's easier to append one sheet to the end of a section than to renumber 50 pages because we added one more precast curve detail. And so really hoping that this kind of allows us to build moving forward. Another general just thing I want to talk about is the use of notes, kind of a convention we used. Some of the notes will be circled, some will not be. It wasn't just whether we felt like circling it or not. We did actually have some logic. If it's not circled, it's a general or a clarifying note. What I mean by that is it's either general, it just applies to the entire sheet. So in this case, all lines are 4-inch solid white unless otherwise noted. I'm not going to point out a specific line and call that out. So it'll apply to everything, or it's a clarifying note. Maybe we have a call out, but we just want, we'll say like C note 3. We just want you to take maybe a second look, a little bit further detail. If it's circled, it means it's just called out in the drawing. Simple as that. Every circle note might just be a really long call out. It might be a call out with nuance. It might be something we want to, draw a little more attention to than just like a random, call out on the actual drawing. So one of the kind of new or improved sheets in these standards is some standard cross sections, which we built out just a little bit better. So this is classified by street width. So we have between 42-foot and 52-foot wide streets, which is really like the majority of larger streets and standard streets in Chicago. And the goal of this is just to, first glance, you got a project, you're looking at a street, what can I do with it? Well, here's 4 options for a 42-foot wide street. Generally, we're gonna lean towards the one that has the best bike protection or pedestrian protection. But we're also have to consider other things like, okay, is there parking on one side or both sides? Or is there no parking at all?
Generally, if there's no parking, you can do a lot with the roadway, but if there is parking, most constraints, most do have that constraint in Chicago. And the other is whether it's a CTA route or a non-CTA route. That's, as has been said before, we want to work with CTA. We don't want to just, take all of the roadway and put it to bikes when there's other users in mode share that we need to consider. And so sometimes that just means tweaking the bike lane width by a foot or 6 inches. Sometimes it means we can't put certain types of bike lane. So the goal of these is just to provide that kind of first glance. Now, you're all transportation engineers. This is probably the easier part of a street where it's straight and nice and easy. It gets a little more complicated when you hit an intersection. And so this is an old standby. It's been in our existing standards. So we've revamped it a little bit. It's just sample intersection design. So this is again classified by different street widths. Now, no intersection in Chicago is going to look like one of these. Now, first of all, because most of them don't have like this exact geometry and this exact cross section, but also because the goal of this is not to say this is exactly what you should copy and paste and put right onto the road. This is to say, okay, here are the elements that work in this size of intersection, this type of intersection. Choose which of them make the most sense for this context. Maybe the bike box, like you see in the bottom here, makes sense on both approaches to the intersection. Maybe it doesn't make sense on either approach. The goal is that you can see how that interplays, how that's going to work with other elements. And then, as I mentioned earlier, MOT is something that we've been talking a lot about this year. On the left, you can see that there's a project that was mid-construction here. So paint's gone down, but concrete's not in yet. And I live pretty close to this street. A lot of people use it all the time. You park the way that you've always parked, right? These lines, they look kind of wide enough for me to park in. I'll just park in that. Well, I know that that's supposed to be a bike lane, but it's not quite clear to the average user. And so we want to look through, okay, how do we as engineers set up our projects for success even in that interim period by creating good MOT standards? So the diagram that we've drawn up and are going to start implementing specifically for parking protected bike lanes just includes putting barrels spaced evenly between parking and bike lane, just to like delineate that space better. If a car is trying to squeeze in between those barrels and the curb, it's like 5 feet. So good luck with that. We also want to make it really, really obvious, right? The parking chalked onto the parking lane makes it clear. You drive for the first time, you're like, wow, they just repaved this road. It looks great. Look at all this nice new paint. Oh, I parked there. It says parking. Nice and easy. The other thing I want to point out is the notes here. We've included this note on a couple of different sheets here, and it's just that temporary traffic control devices should be present from the beginning of construction all the way through the installation of signs and pavement markings. That's to avoid kind of that interim period where there's really no guidance, where most street and road users are just kind of going to treat it the way that they used to, even if it's completely striped differently. And so keeping these from the very beginning until concrete gets poured will really help that confusion and really like lead to project success as we move forward. As Kurt mentioned, the MUTCD is a big part of the guidance that we talk about. One of the ways that we've interpreted the MUTCD in the past, we've clarified and had some really discussions on internally, and that is the delineator color that we use on facilities in the roadway. So the MUTCD says that flexible delineators should reflect the color of the pavement marking they are meant to complement. So what that means is for traffic, separation of traffic in the same direction, delineators should always be white, like you see on the left, where the pavement markings would also be white. Where traffic is in different directions and you're delineating that separation, it should be yellow, like a pedestrian cut through or any other like bike, maybe a two-way bike lane or a contraflow bike lane where there's car traffic directly opposing adjacent bike traffic, and those should be yellow. Pass it off to Colin.
Okay, so I just wanted to talk a little bit about what neighborhood greenways are before we talk about some of the changes and expansions we made in our guide. So neighborhood greenways are streets that are pretty low stress, low traffic, and they don't need protected bike lanes. So the 3 that we have here, the shared lane markings, contraflow bike lanes, and one-way bike lanes are pretty standard treatments that you would see on neighborhood streets. In our guidance, we have information about wayfinding signage, typical signs, dimensions, and pavement markings for neighborhood greenways. One of the neighborhood greenway types that we've expanded our guidance on is the advisory bike lane. So advisory bike lanes allow for two bike lanes to be striped in both directions on the streets, while at the same time providing them on low volume streets. So if cars were driving down that center lane and there's no opposing traffic, everything is just fine. But if a car was coming in the opposite direction, cars could easily, carefully move over into the bike lane space and pass each other. So in our guidance, we have provided information about the width of that center travel lane, the typical ADT thresholds for using advisory bike lanes, and what to do at intersections. Just wanted to point out specifically that at major intersections, most likely we are going to be dropping our advisory lanes in favor of shared lane markings. Also, regarding neighborhood greenways, we've provided guidance on the types of speed humps that should be used for these types of streets. So sinusoidal speed humps will be used as a bike-friendly traffic calming option. It's easy to guess that just adding bike lanes to a street is probably just one more mode that's competing for the already crowded space on Chicago streets. But we don't want to improve things for bikes like adding protected bike lanes on Belmont, while at the same time totally breaking down bus travel times. So for example, on Belmont, we provided some capacity analyses that showed us which segments would be best benefited by combined bus bike lanes or just bus lanes in general. We've also provided some more guidance on our mixing zones. So mixing zones are where cars and bikes cross paths, and they can typically be some of the most confusing things to design. Our typical standard mixing zone of the 30 feet approaching the stop bar is something that you'd probably see on a minor intersection. But the other two to the top that we have here are things that are just general guidance. They're giving information on tapers, dimensions, signage, but realistically, in the real world, each intersection is going to have something unique about it, which might mean that these are going to be very different from what you see here. Ideally, the general goal with the mixing zones is to provide protection for as long as possible up to the intersection and creating the shortest mixing zone feasible. Also, we've provided more information on the protected bike lane corner clearances. Our previous iterations of our design guide were a little bit more specific. So if you had stop bars and crosswalks, and we decided to make it more general, measuring from face of curb to end of parking lane line, while at the same time existing guidance is still applicable. So things like 30 feet approaching the stop bars and 20 feet on the departure of crosswalks, that is all still applicable to these corner clearance standards. This is just very specific to protected bike lanes. And now I'm going to pass it to Gina to finish up.
All right, we've talked a lot today about protected bike lanes and different types of concrete. This was something that was touched on a lot in our previous design reference manual, but we've expanded these sections in this upcoming draft to include more details based on land use and different types of protection. So on the left is an example of the details that we have that shows the placement of the concrete based on this land use, whether it's parking or not, and then whether it's residential, commercial, or industrial use. And these are something that has also come from the lessons learned and meeting with different stakeholders, business owners, and even the MOPD we met out with and discussed potential parking configurations with the bike lane there. And on the right, you'll see some other examples, one of them being quick curb placement, others being rapid delivery, protected bike lanes. Typically, we're going to be shying away from delineator only protected bike lanes. We would only use this in stretches of high passenger areas like daycare and school loading zones, for example. We've got more details on protected corners, end caps for different types of uses, street contexts, and street control. These are just some examples on the left. Colleen talked earlier about Belmont and Kedzie and the protected intersection there. And people frequently ask us if we have any template for a protected intersection, but the answer is no, because not all of the intersections are very different, and it depends on a lot of different things. And what you're supposed to do is be using all these different individual components end cap design, protected bike lane design, corner clearance design, for example, to build your own protected intersection. This is something we're going to be doing going forward more, starting with Wabash in 2024. And as we touched on earlier, there are two different main types of concrete we use, the cast in place and the precast. For cast in place, we've expanded some of our details in the design reference manual, and we're going to also be calling out that the minimum width for excavation is 1 foot wide for the cast in place, which is something that has come from lessons learned over the last 2 years as well. And then for precast, there's 3 types, 1, 2, and 3, as Kurt talked about. And then each of those have subtypes based on if the ends are rounded or not. And you'll see those in the design manual as well. And the biggest thing that you'll see here is the lateral clearance placement. And all of these have different lateral clearance, 6 feet and 6.5 feet for depending on the type of concrete. And this is important for many contexts, but one of the biggest being maintenance. Our mini snow plows and street sweepers have certain minimum widths, and that's why we have to keep a lot of these minimum widths here. So that's the main portion of our event. We are going to wrap up with question and answer. We'll start with in person, if that works. Does anyone have a question?
Is there any guidance for the bike signal required?
Yes, actually. So that wasn't in the presentation, but we've been working on, and it's really adapted. Like I'd point you until we do send this out to the MassDOT separated bike lane planning and design guide. They have a really good section in there on when a protected intersection versus a mixing zone versus full signal separation is required. We have modified those standards really from Chicago specific projects and lessons learned. So we will have a section, I think it's appendix B or C, I don't know if you remember off the top, but we will have a table on that really provides some guidance on where signal separation is required. It's really based on the number of turning vehicle volumes across the bike lane, and also whether the bike lane is one way or two way, and whether those turning movements are left turns across a one-way bike lane or right turns, and whether you're across multiple lanes. So a lot of different things to consider, but it's all on the table. We will share that.
When will that be?
Hopefully soon. Anything that, so I guess in general on process, this would be a good time to say is all of this, like as we are done with pieces, we're sharing them right away and using these standards right away. There's not like a waiting period or like don't use these right now, right? If you're doing work with our group and we have these standards, we will be sharing them with you. I want to make sure that everything is like fully vetted, especially tables like that. There's a couple of appendices, specifically the design vehicle selection table and that bike signal table that I need to vet with more folks just because it's not just specific to complete streets. And so those appendices may come out a little later. But if you're working on projects for us, we'll be talking about those and using those, and ultimately we will share those with the broader group.
How are you guys using level of service or thinking about that for some of these projects like the Belmont project?
Yeah, I would say like level of service is in like the level of service grade we never really look at all.
Okay.
And it doesn't mean like we're doing capacity analyses, we're doing VISN models, right? I'm not saying that the capacity doesn't matter. It very much does. But what we're really looking at, like we run a lot of sim traffic, we do a lot of observations, like how is this actually operating in the real world? And then we're looking at delay and queuing. I would say queuing is a huge thing. Like that's what we're really looking at. Because realistically, and I don't think I need to preach this to this group too much, but the capacity for if someone's expectation for the amount of delay at a particular intersection in an urban environment is very different than at a rural kind of four-leg intersection with much less traffic. And so just looking at traditional level of service isn't as helpful. You really need to contextualize it. But yeah, like queuing, especially if you're looking at like spillback queuing to another intersection that is occurring because of what you're installing, that's really impactful and has spillover effects to other intersections. So we want to reduce that as much as possible. So yeah, it's a lot of like looking at individual movements and where do we need longer right turn storage? Do we need to extend this left turn phase a little bit? Like the level of detail we go into to refine these intersections is really high because there's not a lot of free capacity to just take from wherever. We're doing, you know, pedestrian intervals that, you know, eat into your overall time that you have in an intersection. We have a lot of complex, you know, 6-leg intersections where there's just not time to steal anywhere. So we really are looking kind of movement by movement, isolating what's really the issue. We look at volume to capacity ratios, right? Like where are we over one, and we need to do some like micro simulation to really understand what's happening here, because you know Synchro kind of doesn't do a great job of modeling things when you have volume to capacity ratio approaching or over one. So it's a lot, but there's a lot to it, and it really is like looking at individual movements, and it's kind of intersection specific what we need to see.
Just for the benefit of the people at the webinar, can you repeat the question?
Yes. And
Yeah,
that
you can
question,
keep going.
that question was basically, do we look at level of service or how do we use that in street design?
Thank you.
Regarding the Department of Justice consent decree around accessible pedestrian signals, do you think that'll be incorporated in some of this future work? Is there like going to be some kind of synergy is maybe not the right word, but opportunities to kind of blend that with some of these ongoing retreats work?
Yeah, so the question is how the ongoing consent decree and basically where we do APS and where we do other signal improvements, if those requirements are going to be incorporated into whether these standards or the work we're doing, and really you know, talking about collaboration with other groups as well. And the answer is absolutely yes. What triggers the requirement to upgrade a signal to have an accessible pedestrian signal at every crossing is still not particularly clear, even with the release of the final rule from ProWag. And so we are already having cross-division conversations about what CDOT's interpretation of this is going to be. And obviously the consent decree, like it's going to have very clear requirements, but there's broader requirements with ProWag as well that we need to think about. So the answer right now is we don't have perfectly clear guidance. We do have guidance that we've been working from, and really are often quite conservative about, you know, upgrading, and Chicago has a reputation as a really great place in terms of like ADA infrastructure and being ahead of the game on some of these things for a lot of different reasons, and will continue to be, but it's there's still some clarity that needs to form on some of those things. I'll go closest to me first, then we'll go over.
Have you had any issues with the precast bike lanes next to parking being a trip hazard for cars?
Yeah.
What is the solution?
Yeah, question is on whether the precast curbs, there's any issues as them as a tripping hazard when used in parking protected bike lanes. This was really critical when we started this program. We met, as Gina mentioned earlier, with the Mayor's Office for People with Disabilities when we installed the very first precast curb protected bike lane. One of the things that we have not shown yet, but that we are working on, and that comes a little bit from ProWag and those conversations with MOPD, is guidance for the designation of accessible parking spaces in parking protected bike lanes, which is something that we have not fully fleshed out and is going to need to get fleshed out very soon here as we go into 2024 and with ProWag Live. But part of what we have been doing so far is making sure that we are not just installing concrete curb through the entire length of parking protected bike lane sections, that we are designating, I shouldn't say designating, that we are keeping free the first space closest to curb ramps. We're not installing curb through there anymore. You will see that in these details. And the reason for that is that ProWag requires that first space closest to the curb ramp to be the one you designate as an ADA space if you do it. So we're thinking about that. We're trying to get ahead of it. We don't have final details on what that's going to look like, but it is really important. And we do have some spaces on projects, and Dearborn is a good example where we had existing ADA spaces where we had to build a new ADA ramp as we pushed parking away from the curb, or we needed to shift an ADA space so that it had access to an existing curb cut. We had to omit concrete. So it's something that all cities are really working through right now. And it's a major balance because that's safety and accessibility were the first two things on there, and both of these things go hand in hand. We want to make sure that, street works for everybody. So, yeah.
And as just building on that, as far as tripping hazards go, as I mentioned, we'll do delineator only protected sections in places of like school drop off and pickup zones for that reason.
Them too.
Yeah, so with the protected bike lanes and parking, I know that there in the standards, there were some recommendations about having like, no parking for 30 feet or 60 feet before an intersection. And based on what I've seen, there's not like a specific guideline for when that 60 feet. And I'd seen it a couple slides ago. So I was just curious about like where that 60 feet was coming from.
Yeah. Okay. So the question was on kind of clarification on the protected bike lane corner clearance standards. So this actually specifically came out of some conversations and observations on some of the parking protected bike lane projects that we had installed this year. And one of the things that we saw is that this standard here, we had originally used 40 feet. And this a little bit came from that MassDOT guidance I mentioned before. But we found that there's a lot of variation in where the curb ramps and where the crosswalks fall. And there's a lot of variation in the amount of visibility that a motorist actually has here based on how far back this crosswalk is, how far back this stop bar is, whether, whatever land use is here, whatever building is here is built up all the way to the right of way. And so, we had a couple options. One is, all right, we have some site triangle standards that go into doing an observation and calculation every time that you're here on, okay, what based on how far back you are as a motorist, what exactly can this be that you can get away with? But the fact is, like, 40 feet wasn't enough in a lot of situations. Just anecdotally talking with people who were driving on the street and turning and just, felt like they didn't have enough time to see a bicyclist when this was only 40 feet. Bicyclists who felt like they couldn't really see motorists for long enough turning on the street. So there's a lot of feedback there. And 40 to 60 feet was that is what fell within all the existing guidance that we saw with other cities. And so given all that feedback, we decided to settle on that larger corner clearance standard specifically for protected bike lanes for that reason. That's where that 60 feet comes from. Far side, 30 feet. That's just because you don't have bicyclists coming in the opposite direction. You don't need to worry about that left turn visibility. So you're able to shrink that down to 30 feet. You don't need the same 60 feet. You don't have any fast road users coming in that direction that you would need to be worrying about. So that 30 feet is specific to far side. And then the 20 feet beyond a crosswalk, this is standard whether it is a protected bike lane or not. So that's a common standard. We just wanted to have a standard here as well in case there was a location that did not have a crosswalk, which has come up a lot on some projects.
And with the 60 feet, do you recommend it for all intersections or just signal lines?
So this is specific to uncontrolled intersections, right?
Yeah, there's going to be a table in the design reference manual that lays out the type of control, whether or not there's a crosswalk and a stop bar.
Anything real quick before I get to you? I want to make sure anything on the virtual chat.
Yeah, we have a bunch of questions.
Okay. Do you want to look through and curate those? I can take one more
and
and
then
then.
condense some of these together.
Okay.
One of them is, does the Complete Streets group regularly meet with livable streets / streetscape? Will these diagrams be available on the CDOT website? And is there a way for CDOT to gather information from the consultants?
Yes, not yet, but soon. Yes. Yeah, absolutely. We're working a lot now with other groups and setting up recurring meetings to, again, that's where I kind of got into some of these guidelines require some refinement before we just release them to the masses and put them on the website. So we're figuring that stuff out. But yeah, that coordination is definitely has already started and will continue because we really all want to be on the same page on these guidelines. Again, really important for us to share this now because we're using these standards now. We need to design for these. So if we waited until like every detail of every detail was fully vetted by everyone, you know, we would not be using these standards yet. We really need to use them. So those pieces will come. If you are working on projects for the city and there are specific questions that you have, or you want to see some standards, or you don't know where, reach out. Absolutely. Talk to your project manager, whoever your CDOT project manager is. Really encourage you, like, oh, hey, I saw this, or, you know, do you know about this? Like, we're all talking too, but we're all working on 100 different things at once. So good communication with your project manager is super integral to success. And then we get to hear about the project early if we need to do any review, but certainly we can share standards as needed on any of these things.
So applications for the raised bus stops are being
Mhm.
installed on the island, especially where the bus is stopping and just that single travel. Have there been any like before and after queuing analysis or observations that was done to see how those impact?
Yeah, so question is on if there's been any queuing analysis or observations at bus boarding island or bus bulb locations where buses are stopping in the travel lane and vehicles have to keep behind them. We've done preliminary observations. We have done a lot of before travel time assessment on a lot of these corridors. We literally, our staff was on buses and then in cars at doing travel times during the AM and PM peaks. So a lot of hours spent on that. A lot of these projects are just wrapping up and we really want to have them settle in before we do a lot of the after observations. So unfortunately, a lot of that is going to come in the spring. We don't have that empirical data quite yet. But we have done a lot of just rough observations to see how some of the bus bulbs and boarding islands have performed. Milwaukee is a great example. In general, what we see is that the dwell times for these buses has been reduced. So whereas maybe they stopped for 14, 15, 16 seconds, they're only stopping for 7 seconds now. So they stop for a shorter period of time. And in general, we're doing these at mid-block locations where queuing is not stretching back to the next signal. It's not stretching back to the next controlled intersection. Will we get it right 100% of the time? I hope so. But all of this is very new and we've been learning, but in general, it's been what we have seen has been very successful. I think we'll be working with CTA a lot on getting feedback from operators on how it's been using these things. What speed do they approach them with? Have they had issues with people trying to drive around buses at these locations? So we'll get a lot of feedback, but in general, where we've been doing them has definitely conformed to a lot of other national guidance out there. We've had good preliminary feedback in general, and then definitely excited, very excited to get empirical data next year as we do more observations and analysis.
Okay, we'll shift
Hold
to-
on, we got Tyler back here.
I know this is not really why you're all here, but I did want to make one clarification on something.
Tyler, first of all, you have a mic here
Oh,
for people
sure.
on the webinar?
He just won.
Can you go back to the EFT one or the?
Oh, yeah.
Process?
Yeah, please.
Again, maybe I just can't avoid inserting signal stuff in
No,
here.
I offered it up that you had to do corrections, so.
As long as people are listening, I think the point is, these are important things to submit for the process, but it might not be everything, right? If there is auto turns that have to happen, that goes in with your TSR. If there is a new signal that's getting built, submit the study that went with that. Timing sheets, you need a synchro file to build your timing sheet. You need your crosswalk stuff. You need volumes. Just saying that isn't just the standalone document. I feel like I have to just say it. So, thank you.
Yes.
Thank you for that clarification. We'll take one of these webinar questions. With the shift to rubber speed humps versus a combo of rubber speed humps and quick curbs, are we concerned that the efficacy of the left turn hardened center lines will decrease, particularly if snow is involved?
So questions on the speed hump versus using the bollards along with left turn traffic calming, is that right?
Yes, Sid can speak to that too if you need.
Sure.
him to.
Yeah, I think in general, these are all like pilot locations that we're currently evaluating. So in terms of efficacy, one, I'll say just from preliminary observations, we have not seen much of a difference in terms of how well these left turn traffic calming locations are performing in terms of slowing speeds, in terms of vehicles taking left turns, and limiting the amount of pedestrian exposure at the intersection. So I don't think that we've seen, at least with what's out there right now, any change in efficacy between just rubber speed bumps versus rubber speed bumps and quick curb with bollards. I think the question about winter maintenance is critical, and the truth is we haven't gone through a winter yet with these out there. So that's part of what we're evaluating. In general, we've seen that the rubber speed bumps have held up really well, which is a part of that shift, and they also are working just as well. The question will be, how do they hold up in the winter, and are there changes we could make, whether it's adding delineators or things like that would help them hold up long term? Anything to add, or is that?
No, that was perfect.
There you go.
All right, one more. Do you use a special HMA meant for lower loading than a typical vehicle loaded, chain mix?
Yeah, we don't yet, but we've been talking about it because that is totally possible. So if, oh yeah, sorry. The question was if we used I thought maybe you could hear the mic from here. Whether we use a lower classification HMA mix for the bike lane because it doesn't receive the same, like the most loading it's going to experience is when you're actually pouring the asphalt. And then it's, bike lanes and then maintenance vehicles, which are much smaller and more infrequent. So we are not using a different HMA mix right now in the protected bike lanes. It's the same as is the surface treatment on the rest of the street, but it is something we have talked about. If there's a cost benefit that we see for that doesn't delay us, because time is also an issue. If you're using a different mix for a different element, then that's something we'll definitely consider. And whoever asked the question, if you have thoughts on it, please let me know.
Any exploration being done of vertically separated sidewalk level bike lanes in Chicago?
Okay, so any exploration on vertically separated bike lanes, basically raised bike lanes or off-street bike lanes? Yes, absolutely. I cannot wait for the Wells Wentworth connector to finally open. No, I do not know when it's going to open. But that is one example. We actually just installed on Clark between Irving Park and Montrose a raised bike lane through a bus layover space. Another item, we've been coordinating with CTA. That's a small section, so we want to do more. It's a really big capital improvement to be changing the curb line and moving bike lanes off street. There's a lot of utility impacts, but it's something we absolutely want to do more of, and we'll have some opportunities through whether that's coordination with streetscapes or reconstruction projects and engineering, maybe certain special AR projects, or others depending on funding source and scope and scale of the project. We're definitely looking for opportunities to do more off-street bike lanes. Laramie, that's a great example. We also have been doing, even on routes with conventional bike lanes. Belmont already has this installed. Laramie will get it next year, where bike lanes will shift to the curb and then raise up at bus boarding island locations so that the bike lane is going behind the bus boarding and alighting area and raising up to sidewalk level. And we usually do these integral with a raised crossing. So you stay raised through the intersection, through the bus stop, and you come back out into a conventional bike lane, really focusing the improvement on where the highest risk of injury in a crash is, which is at the intersection. And we do actually have some detail on that in the guide. And we also have some examples. That's kind of new, but something we're going to be doing more and more of.
Okay, one more. Earlier, it was mentioned that a cast-in-place protected bike lane paved in asphalt should be at least 5 feet of asphalt wide for construction purposes. In one of the photos of the Belmont repaving, Belmont appears to be repaved fully curb to curb with a cast-in-place raised barrier being cut out and installed. Is this typical construction method?
Yes. So to simplify the question, basically, how are these concrete curbs that are cast in place installed? Really, what's the phasing between the HMA installation and concrete curb installation? Because we had shown some minimum paving widths. It's been done really in two ways. One is to do your base course and then install concrete curb before HMA paving, and then pave with HMA after that. A lot of that is dependent on MOT plans, phasing plans, what's out in the street already, a lot of intricacies to deciding to do it that way. When you do it that way, that means that you are paving that space between the bike lane curb and the existing curb line after you've already installed the bike lane median. And that's where it's really critical that you meet that 5-foot minimum because you need to get equipment in there. How it is often done, especially when we only have a few cutouts, right? We only have a few end caps or a few lengths of concrete. It doesn't make sense to create these barriers to pouring HMA when it's a very minuscule portion of the project. It's actually much cheaper. Cheaper maybe is not the right word. It's much less time consuming, which ultimately means cheaper, to just pave the full width curb to curb with HMA and then saw cut and pour concrete afterwards. And when you do that, that 5-foot minimum may not be critical for the actual construction of the project, but that area will eventually need to be resurfaced in the future. So it is still critical to meet that 5-foot minimum because if there's any reason, if there's utility work 30 days later, that's emergency utility work and someone has to cut into that pavement, then the only way that they're going to be able to repave that is hand method, which is not as good of a product. We don't generally want to do it if we don't have to. So yeah, hopefully that answers the question.
Thank you for that. The next one is, are the aldermen on board with removal of parking in commercial areas to have one-side parking of 42 feet wide?
Sid, did you type this question? So simplifying that question, it's are the aldermen on board with everything that you want to do all the time? We work very closely and happily with all the aldermen of all 50 wards of the city of Chicago. And we are always seeking feedback. Yes, there's always challenges. There's always businesses who call the ward because there's an issue that we didn't anticipate. It's why we had the lessons learned that we had on the presentation about curbside use, about the appropriate design vehicle. But man, our team does a really awesome job of working closely with the wards to resolve issues that happen in the field, but even more than that, make sure that issues don't come up. For every issue that we have to tackle in the field during construction, there are 100 more that we have caught in advance to make sure that this project is as successful as possible. And it's why we're not making big changes to projects when we're after we're going out and installing them. There's a lot of education, there's a lot of acclimation, and that's always going to be the case with big changes. And so yeah, there's always some give and take and some conversation and coordination on things like parking removal, but at the end of the day, we work through it with individual wards and businesses and stakeholders, and ultimately get the best product we can out.
And then just in the interest of time, we'll end up with this question. Has there been noticeable or measurable reduction in pedestrian and bike crashes or fatalities correlated to the safety improvement installations?
Yes. Have there been documented notable empirical improvements to safety and reduction in crashes based on our improvements? Project by project, yes, we see it over and over again. Even before we have crash data, we get speed data pretty quickly. And when Gina says that there's been a 90% reduction in the number of vehicles driving over 30 miles an hour on Kedzie, that's not crash data, but just look at the crash statistics that I showed before and that chart on the power of speeds over injury and serious injury and fatalities. When we see that speed reduction, we know we're going to see that serious crash reduction. And then when we go back year over year on these projects, we see it over and over and over again. It's why we do this. It's why so many people in this room do this and listening virtually. So yeah, absolutely. We got like one more minute. Are there any questions? Because I know we focused on the virtual a little bit, but any other questions for the group in here? Okay, last question.
For some of those streets where you add like speed humps.
Yeah.
And they go into the bike lane, is there a reason why you extend the bike lane?
So the question is why we have speed humps that maybe enter the bike lane and aren't cut off at the bike lane. Honestly, that one is, I'd have to see like project specific. It depends. Generally, like the speed hump may predate the bike lane, you know, it may have already been there. And we also, you know, have to be cautious about creating a hazard where, you know, there's snow on the ground and a bicyclist hits the edge of a speed hump and that causes an issue. So I don't know for sure on that one. I'd have to look case by case. If you have something that you specifically saw, you'd share it with me. But
I think there was a slide.
was that in the, maybe it was in the like
I think it's
early? Oh. I regret those animations. Right there. Yeah, okay, so this is a parking space. Bike lane is here. Yeah. So, there you go. All right. Sure. 30 seconds on sinusoidal speed humps. Yeah, this speed hump specifically, it's called sinusoidal. We call them bike friendly as well. Basically, it's like wider but more gradual speed hump. And it's meant to do more of what speed humps are meant to do, which is have slow, consistent speeds and not have vehicles come to almost a complete stop, get over the speed hump, get all angry, and speed up to the next speed hump. It's about slow, consistent speeds, and it's also a lot more comfortable for bicyclists to ride over. Details in the guide. Thank you so much for listening.